Today's topic is spline curve. As before, before I start this video, I want to tell you that if you want to learn from this video, you have to go first in the last video where I taught you about the continuity. That is so much important topic in this topic. So you have to first know about the continuity, then you can understand very well to this topic. Okay, so now we will start about this topic, spline curve. So what is the use of spline curve? What is spline? First we have to know about this thing. So spline curve is that will be used for design, control, modify to the complex shapes of the curve. Means that if you want to draw a curve, complex curve, that time that spline is will be useful. How we can say that? So first of all, I want to tell you the history of spline curve. So first, spline curve, the spline word is coming. What is mean of spline curve? Spline word. The spline word is coming from ancient era when the ships are there. Means that if the very years ago, some years ago, the spline is coming from one tree, that name is balsa tree. The balsa tree have there are some in the balsa tree stems are there. So when stems have to be removed from the tree, then that will be removed as a very thin strip. Okay, that thin strip is called the spline. That will be so much flexible, so that flexibility will be used for making the curve, and it will be used for making the ship's design. Whenever any object in the ship, any dimension of the ship will be moved somewhere or mold somewhere, or some curvature design is coming in the ship, that time we have to use to make that design is spline. Okay, so when you want to make any curvature object, a curvature design, then that design will be made by the help of spline. That will be the fine strip of balsa tree. That's why this curve name is coming spline curve, because the same concept we are taking here in the mathematical form. That's why this curve name is spline curve. So how we can make curve with the help of spline concept, and what are the mathematical equations are there, we will discuss in this topic here. Okay, so now we can understand what is a spline curve, what is the use of spline curve, and where that word spline is coming. So now we will discuss about the mathematical representation. So in the mathematical representation, first condition is there, the C1 and C2 are continuity is already in this spline curve equations. Whatever equations are there in the spline curve, that equation follows C1 and C2 continuity. Hope you already got from last video that what is the C1 and C2 continuity. So if you don't know, please go through in that video, then you can understand what is the C1 and C2 continuity. But I want to tell you the exact idea what are the C1 and C2 continuity. These are the continuity have two types. First one is parametric continuity, and second one is approximation. Parametric continuity, and second one is geometric continuity. So in the parametric continuity have three orders: zero order, first order, and second order. So in the parametric continuity has been shown by the C. So if that first order continuity will be there, first order parametric continuity will be there, that then we have to show C1. If any equation will be follows first order parametric continuity, that will be showed by the C1, and if that equation will be follows second order continuity, parametric continuity, then that will be denoted by C2. So both continuity will be follows by the spline curve equations. Okay, so first condition in the spline curve equations are follows by C1 and C2 continuity. Okay, and these spline curve equations are strictly follows in cubic polynomial form. Hope you already go through in the first or second video in this curve and surface unit. Then that time I told you that what are the forms of the curve. So in that forms of the curve I told you that what are the cubic and what are the quadratic equations. So in the cubic equations have points are in curve is 4, then that degree of equation is 3. So here always spline curve equations have a cubic polynomial form, means that they are the points in the curve is 4 and degree of that equation is 3. Okay, as I already told you that you can make 5 to 6 and 7 8 9 etc. any type, any number of points you can take in the curve. But as I told you before also, the best curve if you want to make, then maximum 4 points or 5 points you have to take it. Okay, so here the spline curve, spline curve having cubic polynomial form means 4 points are in the curve. Okay, so here now we are coming on the first now we are talking about the points. So that points are also called the control points, which will be used for control or modify the curve shape. Okay, so in that point the curve will be depend on that points only. In the points are making the curve, so maybe that curve will be covered all the control points or not also, means that if we have these 1 2 3 4. Okay, so if we have these 4 control points are there and we are making the curve is like this, so this is also the curve. And if we have these 4 points and this curve is like from like this. Okay, so this type of curve is also acceptable in the spline curve. So same thing I am telling you that the curve is covered all the control points or cannot be covered all the control points. This is the condition of the control points in the curve. So every time whenever you want to make the curve, that curve is made by the control points. Or if you want to modify or control the curve, that control or modify by the these points. That's why these points are called the control points. Okay, so here if you want to make the control points, if you want to make the curve, then you have to take 2 ways to make the curve. First way is interpolate. First way is interpolate, or the name is here interpolation points. And second one is approximation or approximate spline. So there are 2 ways to make the curve. So what are the difference between them? Now I am telling you. Okay, so now I am telling you these what are the difference between these 2 spline ways. Okay, so first in this diagram you can see all control points are covered when I am making the curve. Okay, so this type of curve is called the interpolation. Okay, and if all control points are not covered, some control points are covered to making the curve, then it will be called the approximate spline. Okay, so now you can see here interpolation spline is all control points are covered in curve, then this is called the interpolation. And here approximation spline is not all, some are the covered only. Okay, so like this. So in this in spline curves have one equations also. So now I want to discuss about the equation. In general equations is the curve qt. QU, sorry, T is not there, QU. So Q is the curve and U is the parameter. Third parameter, as I told you in the parametric form, we have to take the third parameter. Okay, so here QU is equal to summation of I is equal to 0 to n. I is number of the control points. Okay, for example, here I is equal to 0, I is equal to 1, I is equal to 2, and so on. So here that equation, that control points are in the curve, that will be going 0 to n. Okay, 0 to n means that number of control points are n plus 1. Okay, here summation of I is equal to 0 to n pi means control point, which control point I am in. For example, I is equal to 0, so this I is pi value. Okay, and bin means blending function of that point. Okay, we will discuss later whenever we will talk about any curve. That time I will tell you what is the blending function. Just now in the general equation I want to tell you which type of equation is coming in the curve equation. So every time whenever we are talking about the curve, then always that curve have different equations, but that will be come from this equation only. Okay, so hope you understand this lecture. Thank you.